Hi, it's Robin. I have here The Impossible Fortress, a novel by Jason Rekulak, published in 2017. I don't think I've covered a novel before, though that black book of C128 contained a lot of fiction, and 2017 is very recent compared to most things I show. But I think you'll know why we're looking at it when I read the book's description. This is from the publisher's website. It's May 1987. 14-year-old Billy Marvin of Wetbridge, New Jersey is a nerd, but a decidedly happy nerd. Afternoons are spent with his buddies, watching copious amounts of television, gorging on Pop-Tarts, debating who would win in a brawl, Rocky Balboa or Freddy Krueger, Bruce Springsteen or Billy Joel, Magnum P.I. or T.J. Hooker, and programming video games on his Commodore 64 late into the night. Then Playboy magazine publishes photos of their idol, Wheel of Fortune hostess Vanna White. Billy meets expert computer programmer Mary Zielinski, and everything changes. So I was a 14-year-old Commodore 64 programmer in May of 1987. So this book really intrigued me, thanks to my friends at the Into the Vertical Blank podcast for recommending this book to me. So at times this book even feels like some of the teen movies from the 1980s, and in fact Netflix has optioned the feature rights to this book as of 2019. I haven't heard if they're actually going ahead with a kind of production of it. And for those of you who are parents, just to make clear, this isn't a kid's book. It's more young adult or even adult. It involves adult situations or, well, teenager situations. So to show you how much the Commodore 64 is featured in this book, I'm going to read a couple excerpts. You've probably noticed that this is a super long video. As always, there'll be a chapter index for you to jump around if you don't want to watch the whole thing. In fact, this is going to be a stupidly long episode. I don't know what I was thinking. So let's read a couple little bits here to give you an idea of the book. Mary loaded the game into memory and typed run. To my surprise, I found that my arms were trembling. I was actually nervous. I'd never shared my games with anyone who knew how to program, let alone someone smart enough to design an entire minigame in a single weekend. The title screen appeared with an 8-bit illustration of a foreboding castle. The hero and the princess stood center screen as a tinny theme song played, and then an ogre hauled the princess over his shoulders and dragged her away. "This is awesome," Mary exclaimed. "How'd you draw this?" "Koala pad," I explained. Then I touched it up with Doodle. She leaned into the screen, studying all the finer details. "God, I wish I could draw like this. Her outfit is perfect. You even put a tassel on her hat." I couldn't believe she'd noticed. To research that outfit, I'd spent an entire hour browsing encyclopedias at the library, studying portraits of princesses all over Europe until I found just the right hat. It was called a hennin, and it looked like a giant pointy cone. "Keep watching," I told her. "This is where it all breaks down." The game began, and the brave hero began his quest at the base of a mountain, while ogre guards swarmed all around him. The object was to guide the hero up the mountain, but everything moved in agonizingly slow motion. The characters looked like they were flailing about in zero gravity, a Super Bowl instant replay that never ended. Suddenly I wanted to get as far away from Mary as I could. I felt dumb for trying, and even dumber for sharing. Planet Will software. What the hell was I thinking? But Mary didn't look disappointed. If anything, she seemed more engaged, like I presented her with a problem worth solving. She hit run, stop, and type list, and all my code spilled down the screen. Mary skimmed the lines, nodding as she went along, not reading, but skillfully assessing the overall structure, the way a mechanic might circle an automobile, inspecting the surface and kicking the tires before diving under the hood. For 10 minutes she didn't speak. She read and reread the program, one subroutine at a time, mumbling to herself and occasionally jotting notes on a scrap of graph paper. She never asked me a single question. She didn't need to. Sometimes she'd explain "humph," and I'd lean forward to see what she was humphing about, but she was always moving ahead to the next loop. There was nothing for me to do except sit back and wait. And jumping ahead, I realized this was a polite attempt to turn the conversation away from the game. "I told you it sucked." "You weren't kidding." She restarted the game and guided the hero across the screen, groaning as she prodded him forward. "You could torture prisoners with this game, strap them to machines and force them to play for hours. I've had more fun playing spreadsheets." I forced myself to laugh, but it came out like a whimper. See, I knew the game was horrible. It was unplayable. It was awful. But even with its flaws, this horrible, unplayable, awful game was actually the best game I'd ever made. You want to know the worst part? Mary asked. I couldn't believe it. There was more? There was worst? The worst part is, your code's perfect. There's not a single wasted command. Every line is packed. And the way you toggle sprites to animate the guards, that's fantastic. I love it. And there it was. After 14 years of fumbling footballs and missing baskets and striking out, after 14 years of miserable grades and bad rhythm and terrible fashion choices, after 14 years of being me, I wasn't used to compliments. My face burned bright red. I couldn't help myself. I wanted to freeze time and linger over her exact phrasing. Perfect. Fantastic. I love it. Your only problem is speed, she continued. You need to rewrite this game in machine language. So sorry if that was overly long, but I think it really gives a good idea of what this book is about. It's not just about computer stuff, but it's integrated in the book in a good way. I think it's well written and enjoyable and for the most part very believable. Now, a really interesting thing is that at the start of each chapter is Commodore 64 BASIC code. It's often a subroutine, and presumably this is the code that Mary was looking through in the excerpt we just read. And it's not just random code. Each snippet ties in a way to the story. The code, I suppose, is used as a literary device that ties the story together. It's a great idea and fairly well executed, but it probably doesn't surprise you that I found some errors in the code. Actually, a lot of errors. Now, you might think I'm just being a nitpicker, and it's true that I do find it fun to find mistakes, but the thing is that this code is part of the world of this story, part of the immersion, and presumably Jason Rekulak put in the book to add to the realism. And to someone who really is a Commodore 64 programmer like me, when it's not right, it unfortunately detracts from the story. So this might be a bad idea, but I'm going to try to type in and analyze the code from all 34 chapters. So this is going to be a ridiculously long episode. I think based on the comments and feedback I've had in the past about some of my videos, I think some of you will really like this, and some of you will think this is the stupidest thing you've ever seen. Sorry, I'm going to show each listing in the book as I type it in so you can look ahead and see if you can find any errors, and maybe I'll even make some of my own errors, which I almost always do whenever I have to type in a bunch of code. Now, I do understand that this book is a novel. It's not intended to be a type-in listing of a game. I fully expect the code not to work, and I'm sure it's not even a complete listing of the game. It's just code fragments. But I think there's a lot of interesting things that we can still look at, possibly learn here, and sometimes even bad ideas can be fun. Okay, so I'll set up my Commodore 64 and we'll get typing. Okay, so here I am at my C64, and I'm going to type in the program fragment from the beginning of each chapter. Well, I don't know if I'll do all 34, but I'm going to give it a try. We'll see if it gets too boring or if I fall asleep or whatever. Okay. RAM welcome screen. Of course, we don't have to type in the remarks, but they're part of the charm. 281, poke 3280, 330, print. Okay, of course, you don't actually type in CLR in those curly brackets. That means clear, control, white, and 12 cursor downs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. A lot of magazines back in the day did that sort of thing for their listings to make them more readable. 1, 2, 3, 4, 5, 6, 7. The Impossible Fortress. A game by Will Marvin. 1, 2, 3, 4, 5, 6, 7, 8, 9. And Mary Zielinski. 70 print, 2 cursor downs, 80, 2, 3, 4, 5, 6, 7, copyright 1987, Radical Planet, 90, you can see there's a desire to stay within 100 lines of line space. Not 100 lines, but about 10 lines spaced, usually 10 lines apart. But this last one got squeezed down line 95 just to avoid going into the 100 block. A couple comments. Seems that the remark for every chapter somehow reflects the contents of the chapter of the story, but not always so directly. But in this case, the welcome screen for the game and the opening chapter of the book. And it's interesting, this GoSub 4000, 4500, those are presumably some subroutines, but those are not in this book because there are only 34 chapters, and we'll see in the next chapter that basically the chapter number becomes the first digit in the line numbers after this chapter. This opening one starts at line 10 as most basic programs would, but there are no line numbers in the 100 to 199 range. It's going to jump right to the 200. That's fine. We know this is not a complete program. That's totally fine. Just going to save that as chapter 1, just in case I have a power failure or something. And let's run it just to see what happens. Okay, that error is expected. But yes, sort of like I thought, the formatting isn't really right for the 40-column screen. And those 12 cursor downs do seem like too much. Black background and blue border. Well, I guess we'll leave it like that for some mood. Okay, on to chapter 2. I'm just going to keep cumulatively typing this in. 200 rem, establishing difficulty. 210 print, clear. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 cursor downs. 220 print, select skill level. Print easy 1, normal 2, extreme 3. Well, I guess those are actually 2 spaces between each one. 240 input. Your choice. SL 250. If SL is less than 1 or greater than 3, then go to 200. 260. If SL equals 1, then PK equals 10. 270. If SL equals 2, then PK equals 15, and 280 if SL equals 3, then PK then PK equals 20. 290 return. Okay, well that's definitely a syntax error. Sometimes I wish it would do that, but you can't go if SL is less than 1 or greater than 3, like you would maybe in English. In BASIC, well, we'll just run it here. Run 200. Select your skill level. Oh yeah, and the okay, 1. Syntax error in 250. So let's list that. Yeah, first of all, input already prints out a question mark. So that's why, like automatically, so that's why there's a double question mark here. One within the string, and then one gets printed. And the syntax error is that You must do each comparison as its own clause. You can't do a less than 1 or greater than 3. When you or something, it has to be a valid clause on either side of it. And just greater than 3 is not valid. Okay, and that's expected. This is a subroutine, but we're just running it directly. Guess I should fix that too. Should I be fixing things? I don't know. All right, on to chapter 3. 300 rem 23. Transfer character set. There might be a pun about the characters in this book. Setting up the game. 320 print. Please wait. 330 poke 56334. 340 poke 1,51. 350 for address equals 2048261143. 360 poke address comma peak address plus 51200 oops plus 51200 next address 380 poke 1,55 poke 56334 125 and again exactly 10 lines. Oh, I see I made a typo here. I heard you. Okay, I'm going to save this one before I run it because it involves some pokes. Run 300. Say up the game, please wait. So it's doing... Okay, so yeah. Oh, it did corrupt things. Oh, wow. It really borked stuff. All right, I reset. So yeah, what this routine is sort of trying to do is copying the character set ROM into RAM so it can then modify it for custom characters. It's odd using this variable name, this long variable name, but that does work, although it contradicts Mary's claim that his BASIC program is perfect, and it's just too slow because it's BASIC, they gotta learn machine language. Well, this right here is one of many examples of the program being less than perfect, but that's okay. So some of this seems to be copied from the Programmer's Reference Guide on page 110, but there's also some differences introduced. Oh, and also there's no need to actually name the variable in a next. That's kind of a waste. All right, continuing on, chapter 4. Rem, play theme music. 410, L1 equals 54272, poke L1 plus 18, 128, 420, poke L1, 75, poke L1 plus 5, 0, 430, poke L1 plus 6, 240, poke L1 plus 14, 12, 440, poke L1 plus 15, 250, poke L1 plus 24, 207, 450, for L equals 0 to 25, poke L1 plus 4, 17, 460, poke L1 plus 1, peak, L1 plus 27, 470, for T equals 0 to 100. Next T, 480, next L, poke L1, plus 4 comma 0. And again, squeezed into 10 lines. Okay, let's try running from line 400. I really don't think this is going to actually play any music, but let's see. Oh, it did. Ever cool. Not great music, but hey, it worked. One more time. So it seems to be peaking, the random register and poking it back in. So this is kind of like random music. So I wonder if he wrote this himself or adapted from another program. I don't think I've ever seen this before, but maybe it was something printed in a magazine. Well, that's kind of cool. It's not really theme music, but hey. On to chapter 5. RAM. Introduce variables. That probably has a double meaning as well. Something strange happens in the story, something unexpected. Level equals 1, lives equals 3, timer equals 300. I know that's not going to work because TI, the first two letters are TI, and that's the built-in time clock that I've done videos about before. So I know that won't work. And you can't just assign it like that. You have to assign it to TI string with a specific format. HX equals 24, HY equals 50, AA equals 1, BB equals 256. Oop. Oh man, I have a hard time. There. 540 W1 equals 54276, W2 54283, W3 equals 54290, H1 equals 54273. So these are a bunch of, are those all SID locations? Well, there's the classic video chip, V equals 53248. So that's definitely from the official Commodore. Oh, and something I've ignored up until now, all the listings in the book after each subroutine or section of code snippet, it all prints this, it shows this right square bracket. And that, of course, is not part of the Commodore 64, which always prints out ready, after you've done a list or whatever. That right square bracket, I believe, is what shows up on the Apple II. So that's a weird mix. I don't know if they didn't want to say ready at the end of every block or they forgot. Anyway, that's a very strange change. They could just put the blank cursor there, and even that would be more Commodore 64-like. So yeah, that code is otherwise okay. I keep saving. We've had at least one crash. So run 500. Yeah, so syntax error in 510. What is the problem with line score equals 0? LE equals 0? Huh. I don't know what the problem is with 510. I was expecting this 520, this timer, to be a problem. Oh, you know what? It's probably this OR. Okay, because see, I go SC equals 0. That's just the first two letters, which are really all that's valid. But if I type in score equals 0, syntax error. And that's because OR is a keyword, and you can't do a variable name, or you can't make a variable name that's the same as a keyword. At least most of the time you can't. OR, I think, yeah, right? So that's what the problem is. So to fix that, to make that runnable, you'd have to do something like just change it to SC equals 0. Okay, now we should be able to get past line 510. Yeah. And now the problem's in line 520. And the problem is this timer. So you have to just change it to something like timer equals 300. Run 500. Yeah, now we just get the return without GoSub, because this is a subroutine, but we're just testing them block by block. What is this, unit tests? Chapter 6. RAM instructions. Save the princess. She is. Print imprisoned in a dangerous. And by the way, this, these kind of tropes here, print fortress, your mission is, this may seem really stereotypical, but, being a more modern book, of course, it subverts some of this princess, the guy saving the girl kind of thing. Oh, the formatting was so nice. Print, hit any key to begin. 680, get a string. If a string equals, then 680, 690, return, save, chapter 6. Okay. Save the princess. She is imprisoned. Yeah, it doesn't look great, but, no actual error there. Well, that seems to work okay. So Billy, or Will, had his power supply taken away, but he calls it the power box. And that's a little weird because I don't know if I've ever heard anybody call it a power box. It wouldn't surprise me if somebody's mom called it a power box. I don't remember anybody ever calling it that, especially because Billy probably read the C64 user's guide cover to cover, and there repeatedly it's called a power supply. So it seems strange that a nerdy computer programmer wouldn't use the right term, but hey, what do I know? Oh yeah, and he also says C64s would be obsolete in another year or two. And part of the story here is that this contest is to win a better computer, which feels kind of disloyal to the C64, doesn't it? But even I was drawn in by the allure of a better computer, but never did completely abandon my C64. Chapter 700, RAM. Draw hero sprite. 710, poke 52, 48, poke 56, 48, 728 for hero, or just read H, poke 122, 12, 888, plus HE, H, 740, and next poke 192. So this all looks like pretty legitimate Sprite code. V plus 39, 1. There's kind of like a major logical or conceptual error here. Plus 1, hero Y, so hero X and hero Y. Save. So the thing is, this code, this represents a lack of understanding on the author's behalf. On the C64, you don't really draw a sprite. Like, this code doesn't render a sprite. Instead, what you would do is read in the data of a sprite, like it's doing here, but you just do that one time during the initialization. You wouldn't be thinking of it as drawing. You would think of it as initializing the hero sprite, where here you would have a bunch of data statements that would represent the graphics of the sprite. They'd be poked into memory, and then you would configure the sprite registers to point to that register. So like, here's the sprite pointer, 192, and each sprite is 64 bytes. So actually that's even a typo right here. This 12888 should actually be 12288, because that's where the sprite graphics should be in memory for 192. And then here we're turning on the sprite, poke V plus 21, 1. But this register controls all 8 sprites. So by turning on sprite 0 with this 1, we're turning off all the other sprites. And you certainly wouldn't keep rereading the data and poking into memory over and over again every time you want to draw the hero sprite. So this is taking kind of a modern concept of how graphics are rendered. Everything's redrawn because there's no specialized hardware sprites. It's all just a big bit plane that you're like blitting to or copying to. But that doesn't apply to the Commodore 64. So this whole thing is kind of, even if the code is more or less right. Oh, and also these pokes are reserving memory from BASIC, but of course you can't do that when a program's already running and defining variables. These registers also control where the top of memory is, and then variables are after that. So the reason you might do these kind of pokes at the beginning of a program is to keep BASIC out of the way of graphics memory. So the idea is here, but this just really wouldn't work in practice. Chapter 8, Rem, draw guard 1 sprite, poke 52, 48. So here we go with these erroneous pokes again. You can't just keep messing around with memory like that. For G, guard, I guess, equals 0 to 62, read G. And same with these mistakes about poking the guard into memory. And of course, you'd actually have multiple animation frames for your sprites usually, and those would all have to be poked into memory. Okay, 840, XGU. Okay, so that would be right if it's the next sprite definition. But here, poke V plus 21, 2. Okay, that has turned off the player characters and any other sprites, and it's only turning on the second sprite. So, yeah, this is just not right. Poke V plus 40, 2, 870. Poke V plus 2, Okay, this is definitely wrong. 6x. I assume that should actually be gx. Poke v plus 3, comma 6y. 890 return. Okay, so print 193 times 64, 12, 352. Okay, at least it is being poked into the right place in memory again. This is wrong. This is correct. This is wrong in the sense it turns off all the other sprites. And these are definitely wrong here. Oop, I didn't save yet. I'm not going to run that because it's just going to crash the computer. But for example, if I was to poke a safe par memory, 49152, comma 6x, you see it's just a syntax error. So really that should be gx, guard x, and guard y, even if they're not defined. Okay, chapter 9, rem. Control hero 910. Okay, so the joystick equals peak 56321 and 15920 if JS equals 7 and HX equals HX plus 2. If HX is greater than 235, then okay, so we're just limiting the hero sprite to it can't go over onto the far right of the screen. C64 screen is 320 pixels across, but it needs 9 bits, an extra bit in a separate register, and that just complicates things. So if joystick equals 11, then HX equals HX minus 2. If HX is less than 24, so this is just some boundary checking to keep the sprite on the screen. This seems pretty decent. If HY is greater than 229, then HY equals... Oh, 990. If HY is less than 50, then HY. Okay, so this code's basically right, but it does only allow for 4-way movement, which might actually be fine for this game. You know, it doesn't allow 8-way movement. This is suboptimal, that really you only need to check the HX boundary after you've changed HX, the hero X. So really that should be strung on after here, like with if HX, because otherwise you're doing this comparison even when HX can't possibly be greater than 255, as long as it's initialized properly. The other thing, this is just limiting it to the screen, and I think really this game is meant to be like a scrolling game based on the Java game that was made. Or I don't know, it was Java. There's an online implementation of this, not for the Commodore 64. It's C64-esque, and it scrolls. So this game doesn't allow for the sense of a world coordinate. It's just limited to one screen. Oh boy, how are you doing? I'm hanging in here. Chapter 10. 1000 rem. Draw princess sprite. 1010. Okay, so this is more of the same. Messing with those memory pointers that really should not be touched. Reading in sprite data. That should all just be done at initialization one time. Turning off all the other sprites again. So we see a real pattern here. v plus 41 comma 3, poke v plus 4, px. Okay, at least it's not 6x again or whatever, like those guards. How's that math? 194 pointer times 64, 12, 416. Yep, that's correct. Oh yeah, hero X and hero Y. For a moment, I thought PX and PI were player X, player Y, but it's hero X, so PX and PY I think are okay for the princess. Okay, not much to complain about there, well, except all the usual. Nothing new to complain about there. Chapter 11. Draw guard to sprite. Well, this is probably going to be very much the same. Oh yeah. All that same nonsense. Same variable names, so that doesn't really matter. They can be reused. Plus GU, comma G, 1140, XGU. Turn off all those other sprites again. I really like how the sprites flicker on and off. Oh, here, GGX, here's a new problem. So for the sprite second guard position, so again, only the first two letters are actually valid. You can make variable names longer, but only the first two are significant or used. So basically, these are the same variable name. They're both GG as far as the C64 is concerned. So whenever you change X or Y, it's just changing the same one variable. So that's a problem. Guess you'd make an array if there are multiple guards. You could go like GX 0 would equal something, GX1, etc. It's probably the best way of dealing with that. Chapter 11. Yeah, I have been writing those other ones because there is no sprite data to poke in there anyway. So there's really nothing to see. Chapter 12. Advance countdown. 12 timer. Okay, so this is going to be a problem. I already explained that this TI is a system clock. We're going to go home, time left, timer, 12:30. If the timer equals 0, then go to 1600, which is probably some sort of death routine. If timer is less than 25, then ER equals 25. 1250. Timer is less than 50, then ER equals 20. 1260. If timer is less than 75, then ER equals 15. Yeah, I understand the irony. If I make a typing mistake and I'm complaining about his errors when I'm making my own, I apologize for the hypocrisy. 1280 if timer is less than 150 and ER equals 5. 1290. So, chapter 12. It's taken longer and longer to save. List 1200. Okay, so I'll try running this, but yeah, there's a timer error here. So I guess we'll call that TMR. We just can't use that system variable TI. Oh, and I gotta change this one too. Okay, so let's try running 1200. Oh yeah, we haven't set timer. So I'm going to add 1285, go to 1200 just temporarily. I'm going to say timer equals 101. And now let's go to 1200. That'll keep the variable that I just set in memory. Let's see what happens. Oop. List 1200. Okay, yeah, these are triggering here. So instead I should do TMR equals 1000. Go to 1200. Okay. Oh, actually, you know what? I think there's one other bug here that I didn't show. I'm going to go TMR equals 1100 and then go to 1200. Now it's that clock, 1000, it's counting down. Okay, do you see how there's a stray 0 left at the end? That's a problem. That's a bug here. Whenever it drops from, say, 4 digits to 3, 3 to 2, so like when you go from 100 to 99, it's going to leave a stray digit at the end because of how this print routine, it just goes to the top right corner. It doesn't clear the whole screen. Of course, that would be very wasteful if it did clear the whole screen. So instead, it just goes to the top corner and prints. But it's printing that full number left justified. When the number drops a digit, like going from 1,000 to 999, it will never overwrite that last digit. So that's kind of ugly. So that's another bug that you'd have to fix with some extra clearing or whatever. Dangling numbers. Don't dangle your numbers. Okay, chapter 13. 1300. Rem. Error buzzer. 1310, okay, for L equals 0 to 24. I'm hopeful this will actually work. S plus L. Because of how that little random music theme worked. 1330. Poke S plus 1, comma 100. Poke S plus 5, comma 219, 1340. Poke S plus 15, comma 28. Poke S plus 24, comma 15, 1350. Did I forget a space here? Yes, I did. 1350. Poke S plus 4, comma 19. 1360 for T equals 1 to 1000. Next, T, 1370, poke S plus 4, comma 18, 1380, poke S plus 24, comma 0, 1390, return. You know what? And I think I just left that. Yeah, I want to get rid of that line 1285 that I had put in there. Save chapter 13. Okay, now this is using variable S. Have we defined that already? Because isn't that L1 in the music is 54272. Yeah, I don't see where that S for sound effect is being defined. Okay, so I'm just going to try and define S also as 54272. And then go to 1300 and see if it works. Yeah, not great, but But yeah, that's, I guess, an error, unless I missed it, where S is also defined as 54272. But in the other code, it was using the variable L1. I don't even know why L1, not S1. Oh, chapter 14. Rem. Assign rankings. 1410. If score is greater than or equal to 8,000, then rank string equals fantabulous. It always seems weird when Americans put OU in anything. Because they seem so allergic to it most of the time. Rank string equals awesome. 1430 if score less than 7,000, then rank string equals great. This could probably be done better with some sort of math, but anyway. Oh yeah, we can't use score anyway, so why am I typing it all in? 6,000, then rank string equals good. 1450 if, just going to go to, I think I said SC, it's less than 5,000, then rank string equals average. 1460 if FC is less than 4,000, then rank string equals not bad. 1470 SC is less than 3,000, then rank string equals fair. Is fair better than not bad? Or worse? Looks like fair is worse than not bad. I don't agree with that. Then rank string equals ugh. Okay. 1490 return. Okay, I'm just going to change that because we can't have that variable name with or in it. All right, save. Oh, what do I even call this? Chapter 14. Okay. I don't think there's anything to really complain about there, well, other than what I already corrected. No real problems. Oh, a tiny chapter 14. Some of these chapters are tiny, like 3-4 pages. Although actually I like that. When I'm reading a book, I love short chapters. It makes me just keep reading one more chapter, which I did do with this book. Did I already say that? I do like this book. Boost score. 1510. If lives equals 3, then score equals score plus 50. 1520. If lives equals 2, then score equals score plus 75. 1530. If lives equals 1, then score equals score plus 100. I got some bonus points, I guess, at game over. If you have extra lives left over. Home, cursor down, that's a thing games really did do back in the day. 1550. DG equals DG plus DX times 0.15. Ooh, fancy. Math. Could use some math in other parts of this to streamline, to shorten the code. 1570. If DG is greater than 50, then go sub 7,000. More code we'll never see. If DG is greater than 100, then go sub 7,500. Not really see any problems there. Chapter 16. Rem. Out of time. 10. Print. Clear. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it really seems that the formatting just was never tested for this program, because it's like, oh, a 25-line screen, so you have to print down 12 characters. But of course, every time you finish a print, it does another carriage return at the end. And anyway, I think everything ends up being a bit kind of low, and a little to the left as well. Insufficient spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 spaces, plus another one. You are out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Another one. Of time. 40. Print. 2 downs. Print. Thy game is over. 1664 delay equals 1 to 1000. 1670 next delay. 1680. If lives equals 0, then 3300. 1690 return. Okay, run 1600. You are out of time. Thy game is over. Yeah, it's a little bit low, eh? Should be up a couple lines, 2, 3, 4 lines. But otherwise, no major errors that I see. Okay, chapter 16. Oh, I'm starting to think I'm going to skip ahead. 1700 Rem. Hero attacks. 1710 for I equals 0 to 24. 1720 poke L1 plus I comma 0. Next I. 1730 poke L1 plus 24 comma 15. Another sound effect. Is it going to be a good one? 1740 poke L1 plus 13, 252, poke L1 plus 8, comma 80, 1750, poke L1 plus 7, comma 40, poke L1 plus 11, comma 129, 1760, for I equals 1 to 100, 1770, next I, 1780, poke L1 plus 11. Okay, so another sound effect probably, messing with the SID registers. Saving chapter 17. L1 equals 54272. Go to 1700. Here we go. Oh. I didn't hear you. I'll save that for the next chapter again. L1, just make sure that's okay. Go to 1700. Oh, I haven't stood up for an hour. Oh. Did I make any other errors? Poke Li plus I, comma 0. Li plus 24. So that's like clearing out the SID, initializing it. L1 plus 24, 15, L1 plus 12, 160, L1 plus 13, comma 252, L1 plus 8, comma 80, L1 plus 7, comma 40, L1 plus 11, 129 for I equals 1 to... So it's like some sort of noise waveform. Oh yeah, swoosh. I just couldn't hear it before. It's a quiet sound effect. Works. Swoosh. One more time. This book was recommended to me by my friends at the Into the Vertical Blank podcast. Thank you, guys. Chapter 18. RAM. Bonus Life. 1810. Lives equals lives plus 1. 1820. For I equals 0 to 24. Oh, this is another one of those sound effect ones. Well, I gotta say, I'm impressed that the sound effects are actually kind of working. This makes me think a little bit better of this than when I was just looking at all that kind of garbage Sprite stuff. 1850, poke L1 plus 5, 0, L1 plus 6, 240, 1860, poke L1 plus 24, 15, poke L1 plus 4, 17, 1870, SP equals 10 to 250, step 4, 1880. Okay, so some sort of kind of sweeping sound effect, I guess. For T equals 0 to 100, 1890, next T, and just to match the formatting there, 1890, chapter 18. Okay, so to run that, 54272 and go to 1800. So it doesn't mute the sound after. So I think we can do that with poke L1. Well, that's annoying, eh? 16. There. So the 17, you add 1 to whatever waveform. So I think 16 is at the triangle, plus 1 to actually gate it, and then just the triangle to end the sound without the low bit set. Ooh. Chapter 19, whoa, more than halfway. A long way to go. Victory screen. 1910. Oh, did that again, eh? 1910. Print. Clear screen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Again, that's too many. You escaped the fortress. If lives is greater than 3, then score will score plus 500. 1940, I'm just going to do a little bit of this. Lives equals 3. Score equals score plus 300. Line 1950. I should use this the screen editor earlier, to take advantage of this. 1960. Lives equals 1, then score equals score plus 100. 1970, that was a good year, I heard. Score is... Oh, I did that again. I should change those all to SC. I'm going to have to edit them. Print your rank is, semicolon, rank string, 1990, return. I gotta fix all those. Yo, escaped. Oh well. Fix that. Okay. Save. Chapter 19. Well, I still got lots of blocks free. So this looks like a bug here. When you print the score in a numeric variable, it always prints a space in front. But when you print a string, no extra space is included. So I think we have to include, I'm just going to do that now. There. Okay, let's go lives equals 3, rank string equals GRUD, and go to 1900. You escaped the fortress. Your score is 300. Your rank is GRUD. All right, chapter 20. 2000 REM. Victory theme music. Oh, something must be up with my E key. 2010. Read Q1. Whoops. Read Q1, read Q2, read Q3, read Q4. 2020, read Q5. If Q1 equals 0, then 4500. 2030, poke W1, comma 17, poke W2, comma 17, poke W3, comma 21. Well, this isn't going to work no matter what because we don't have those data statements. Poke. So if somebody wants to come up with some data statements, I'll type them in. Do it quick though before I'm done making this video. Poke L2, comma Q4. Poke H3, comma Q1 divided by 4. Poke L3, comma Q2. Q5, next J. Okay, so this would take quite a bit of, quite a few data statements to provide data for all these correct pokes, and Q5 would be, here would be the length of the delay. These other ones would be presumably the pitch, Q1 and Q2. Anyway, that's not going to work. We're missing way too many variables. It probably would work. Oh, I'm getting a low battery warning. I should have thought of that. Uh-oh. Camera went out. Okay, we'll just save that. And I'm not even going to try to run that because I know it just won't work. Chapter 21. 2100. RAM. Pause game. 2110. Print. Home. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Too many, I'm sure. Print 1, 2, 3, 4, 5, 6, 7, 8 plus 1. Thy game is paused. That's kind of funny. 23, print 2 cursor downs. 2140, print 1, 2, 3, 4, hit Q2, quit. 2150, print hit any other key to continue. 160, get a string. 170, if a string equals quote quote, then 2160. Okay, so just waiting for the Q key or any other key. Then end. Of course, our commercial program, even a basic one, probably just wouldn't end if you hit quit. Why not, eh? Chapter 21. Actually, it's funny, most C64 games just never do quit. When I had a game published with Lodestar, they required it to quit cleanly back to the Lodestar disk menu. So that was kind of unusual. Go to 2100. Thy game is paused. Yeah, it doesn't clear the screen. I guess that sort of makes sense. A lot of games don't clear the screen when you pause. They'll just print over top. But that's kind of ugly in this case. And the formatting's a bit strange. Let's try that on a mostly clear screen. Yeah, kind of weird formatting. All right. Chapter 22. Fortress is breached for I equals 0 to 24. Poke L1 plus 1 comma 0. Next I. Yeah, that's got to be a bug. It really looks like it says plus 1, but that must be I because it's doing this initialization loop. So I'll change that. Guess I haven't been entirely consistent about when I have or haven't fixed something, but I guess when it's really easy to fix and really obvious, I will. Poke L1 plus 1 comma 200. Okay, so it's another sound effect. Oh, I forgot the space there, but that's, well, I do too. That's pretty authentic, actually. Poke L1 plus 4. Chapter 22. I just check that it actually does get saved each time, because I actually can't see the status light on my SD card that's hidden back in here. So by doing a disk directory, I'm sure that my chapter is saved. All right, L1 equals 54272, a SID address, and go to 2200. Here we go. Dink. Fortress. The fortress is breached. Yeah, okay, that was underwhelming. Chapter 23. Oh, 22 is a long chapter. One more time. Okay, 2300 rem. Alarm sound. Where I equals 0 to 22. Kind of weird how it's just kind of like a random number of registers getting cleared here. Sometimes 22, 23, 24. In a real game, you wouldn't actually wipe out all the SID registers before every sound effect. That'd be inefficient. You'd probably cause like a click or whatever. And you'd actually have music going in a couple channels, even when a sound effect was playing in a third. Oh, I'm having trouble typing now. 1 plus 3, comma 4, poke L1 plus 4, comma 65. Step 5, kind of weird not putting the space in there, but okay. This might be a more interesting sound effect. Like, it looks promising because it has a sweep in it with this 4 next loop. Probably changing a frequency rapidly, so it's not such a static sound effect. I equals 1, 250. Ooh, look, he did a next without the next I. Good. 2390, return. Chapter 23. L1 equals 54272. Go to 2300. Whip! Alarm sound. And not quite an alarm, but still. Whoop! All right, chapter 24. RAM. Captured by guards. 2410. For I equals L1 to L1 plus 24, 2420. Poke I, comma 0. Next I. Oh, yet another way of clearing the SID registers. Instead of doing the offset with the addition, this is actually more efficient because it doesn't have to do the math each time of adding L1 plus I. Well, that's interesting. Poke L1 plus 24, comma 47, 2440. Poke L1 plus 5, comma 71. Poke L1 plus 6, comma 240, 2450. Poke L1 plus 4, comma 22. Poke L1 plus 1, comma 36, 2460. Poke L1, comma 85, 2470. For T equals 1, 2, 250. Next T, 2480. For T equals 15 to 0. Step minus 1. Now that's the time even I would want to put a space after the step, but I don't think it's necessary. Poke L1 plus 24, comma int T. Next T. Oh, I goofed that up. T. Oh, I was back on my Mac keyboard in my mind for a moment there. So this is descending, but with step minus 1, there's no reason. These are all integers, and poke automatically turns, like if you try to poke a fraction, a float in, it just gets automatically, the integer is done automatically anyway. So it's totally unnecessary, it's doubly unnecessary. But maybe during one stage of the programming, there was an experiment with a step of a 0.5 there or something, and it made it seem to truncate, to turn the float into an integer would be necessary there. I don't know. Okay, wait, we're going to try that. Ch24. We shall see what this does. L1 equals 54272. Go to 2400. Okay. Well, I didn't hear anything, but maybe I made a mistake. For I equals L1 to L1 plus 24. Poke I. Okay, so that's just initialization. Poke L1 plus 24, comma 47. Yep. Poke L1 plus 5, comma 71. Yep. Poke L1 plus 6, comma 240. Yep. Poke L1 plus 4, comma 22. Yep. Poke L1 plus 1, comma 36. Yep. Poke L1, comma 85. Yeah. For T equals 1 to 250. T equals 15 to 0. Poke L1 plus 24. Well, captured by guards. Oh yeah, I have to give you an update. In this one, I think our hero gets arrested by the police in real life. So if this is supposed to be a sound effect, it does not appear to make one. Like alarm sound plus 4, comma 65. Okay. L1 plus 4, So I think this is the bit that should be gating it, but 22 is nonsensical. Like it should be, I guess, 17 to gate the sound. Is L1 still? Nope. L1 equals 54272 and go to 2400. There. At least makes sound now. Captured by guards. Yeah, it's just... that just seems wrong. But I really don't know how to fix that one. All right, chapter 25. Are you having fun? I am still kind of having fun. 2500 rem. Oh. Reset score to 0. The hero has had a setback. Oh, I did that again. Score. I'm not going to leave it as score case. SC. Oh, I did 2600. That should be 2510. That was weird to me. I'll erase that 2600. Okay, 2510, 2520. Lives equals lives minus 1, 2530. If lives equals 0, then 3400, presumably game over routine. 2540, print clear 1, 2, 3, 4, 5. 2550, print. Your score is 0. 2560, print. Hit any key to try again. 2570, get a string. 2580, if a string equals quote quote, then 2570. 2590, return. Run 2500. Your score is 0. Hit A key to try again. Yeah, okay, that one seems to work. $2610. Ooh, it's not starting on 2600. Rem clear memory. Oh, I did that again. 2620 print clear down. 2630 print just a moment. 2640 sys 49608. Okay, 2650. Well, that's not going to work. We don't have any machine language there. If int s divided by 43 equals s divided by 43 equals s divided by 43, then poke w3, comma 20, 2660, poke h3, comma peak. Oh, weird to leave the space there. sp plus 1, 2670, poke w3, comma 21, 2680, if nb equals dot, then 4000, 2690, go to 4500. Well, that is some pretty weird code. I don't think that sys will do anything because we don't have, as far as I know, there's no machine language actually in memory, at least not listed. Although legitimately, maybe the code, this isn't the full program we're getting here. That's pretty weird code altogether. I don't know if there's any symbolic meaning there. These strange pokes. That means if NB dot, that's a period or dot on its own, gets translated as 0 by the computer. It's essentially like when it's parsing, I think it knows it's a number and it turns it into 0. Probably it just sees the decimal point and it kind of shortcuts the parsing. So if the first element of array NB is equal to 0, that goes off to 4,000. Otherwise, it goes to 4,500. This is kind of nonsensical, but this is like a traumatic moment where our hero's computer is taken away from him. Oh, apparently his mom was selling the computer. I actually kind of forgot that. To pay for his crimes. Okay, so I am not going to run that one for sure. It will likely cause a crash. 26. Chapter 27, Rem. Draw new hero. Oh, it's got to be more of that sprite nonsense. For x equals 0 to 62. Read A, 2730, poke 12544 plus x, comma A, 2740. Next A, 2750, poke 2044, 196. 2760, poke V plus 21, comma 16. V plus 43, comma 1. 2780, poke V plus 8, comma H. X, poke V plus 9, comma HY. 2790, return. Okay, so it's like using a new sprite, even though it's still the hero using the X and Y position. Really, it should be using the first sprite again and just changing the pointer to a new sprite definition. But that's the same kind of problems we've seen in all the sprite stuff. Print 196 times 64, 12, 544. Yeah, it's getting poked into the right part of memory, but chapter 27. Nothing to run there because we don't have the sprite data. Chapter 28. Rem. Start bonus level. 10, print, clear, 6, 1, 2, 3, 4, 5, 6. Once again, surely to my cursor downs. 1, 2, 3, 4, 5. You have entered. I thought this keyboard's pretty good, but when I try to type fast on it, that goofs up a bit. 1, 2, 3, 4, 5, 6. The bonus round. 2840, print. 1, 2, 3, 4, 5. Fate has given you. 2850, print. 1, 2, 3, 4, 5, 6, 7. 1 last chance. 2860, print. 1, 2. 2870, print. 1, 2, 3, 4, 5. Don't screw it up. 2880 for delay equals 1 to 1000. Next delay. 2890, return. Save chapter 28. Oh yeah, did I mention that this is kind of like a, if it's not an adult book, it's certainly a young adult book. Just quite a bit of language and yeah, I mean, it's all stuff teenagers might do, but it's not a kid's book. That's my point. Well, that's up to you, parent, to decide. Oh, don't screw it up. There, okay. That almost looks like an error seeing the word next, next delay. But no, that should be correct. Okay, run 2800. There you go. You have entered the bonus round. Fate has given you one last chance. Don't screw it up. Okay, kind of funny formatting. But otherwise, okay. Chapter 29. 2900. Rem. Draw new guards. 2910 for x equals 0 to 62. 2920. Read A. 2930. poke 12608 plus x comma a 2940 next x 2950 poke 2045 2960 poke v plus 2132. Yep, we're back again, turning off all the other sprites. Poke v plus 44. That's the color of it, by the way. 2 would be red. 2980. Poke v plus 10 comma guard x. Poke v plus 11, the guard y position. 2990. Return, save, chapter 29. Okay, nothing new there to complain about. And now chapter 30 in the home stretch. Rem. Draw new environment. 10 for j equals 6 to 14 for I equals 1030 plus j times 40 to 1036 plus j times 40. All right. This might do something. Poke I comma 35. Might draw a rectangle or something like that. 30, 40, next I, 30, 50. For I equals 1044 plus j times 40 to 1056 plus j times 40, 3060, poke I, comma 35, 3070, poke I plus bg, comma 9, poke 3080, next I, next j, 3090, return. Okay, there's quite a few variables not defined here. S, O, I plus BG. So yeah, I can imagine this poking to screen memory. So it would draw like a square or a rectangle or something. But we do not have this SO or BG defined, do we? AB. So that might be meant to be the color memory. I'm going to just remark that one out. And that one out. And maybe this will kind of work. Did I save it? Yeah. Okay, run 3000. Oh yeah, there we go. So I guess it's kind of like a level. This is the closest thing to graphics we've seen in this game so far. I'll get rid of the remarks, but those would have crashed it had I run it with those set to 0. Actually, no, those would have worked. Well, they would have overwritten. It's probably supposed to set the color or something. Okay, chapter 31. 3100 Rem. Draw new fortress. 110 for I equals 1345 to 1362. Poke I, comma 35, poke I plus BG, comma 9. So this is very much like the last chapter's code for I equals 1625 plus 15 times 40 to 1642. That's a bit weird. Poke I, comma 35, poke I plus BG, comma 9. Next I, 3170 for I equals 1519, 1542, poke I, comma 35, poke I plus BG, 9, 3190. Next I. Okay, well, I'll try running that without remarking out the BG pokes. This one's basically, yeah, this one's a mistake. Like for I equals 1625 plus 15 times 40, that is a much bigger number than 1642. So that may execute just one time, but actually it'd be poking way out of memory. Ooh, that may have corrupted our program. $16.25 plus 15 times 40. Yeah, that's poking to a weird spot. Yeah, actually, let's see if the program's borked now. I think it made a single poke somewhere into our basic code. Okay. Well, that's kind of bad code. So anyway, I'm going to reload chapter 31, just because I think it might have corrupted something there. And we'll list that. Chapter 32. Wow, did I really type that much stuff in? 3200 rem. Repeat Siren SFX. 3210 for I equals 0 to 22. More of this unnecessary SID initialization. Poke L1 plus I, comma 0. Next I, 3230, poke L1 plus 24. If it really is repeating that siren from earlier, then that's exactly what a subroutine should be used for. But then I guess, so we should be typing this all in again. But I guess that's what it's being used as a literary device. That would be unimpressive for him to just have like go sub 2000 or wherever that was. 3260 for I equals 20 to 140, step 5. 3270, poke L1. Next I. 3280, poke L1 plus 4, comma 64 for I equals 1, 250. 3290, next I, return. It's kind of funny having a loop spread from the end of 3280 to the beginning of 3290, but that's legit. Just he's trying really hard to keep every chapter in 10 lines, even if it looks weird. Oh, Billy, oh, Will, your code is so perfect. It's just too slow. Okay, run 3200. Oh! Oh! I forgot to set the variable. That was a cool crash, eh? Well, that's why you save, folks. Okay, this time L1 equals 54272. This is what I forgot to do. So it was poking, L1 was equal to 0, So it's poking into very low 0-page memory. I guess even right to location 0 and 1, which messes with the memory config. So no wonder it crashed. There. That's our siren again. Whoop. I want to call that many times. Let's see. $200 times. That's actually an okay siren. Like, that sort of sounds like one. It's kind of funny that the code itself doesn't do the repeating. Okay. Oh, second last one, I think. Chapter 33. RAM. Game over. 3310. 53281, 0. 5328. Okay, black screen, 3320. Print clear and red. 3330. Print. 1, 2, 3, 4, 5, 6, 7, 8, 9. My game is over. 3340. Print. 1, 2, 3, 4, 5, 6, 7, 8, 9. You are trapped. 3350. Print. 1, 2, 3, 4, 5, 6. In the fortress. 3360. Print. 1, 2, 3, 4, 5, 6, 7, 8. For all of eternity. I like in things when you get something's going to happen to you for all eternity, but you don't have immortal life, right? So, like, you know, when Han Solo, well, when everybody's getting thrown to the Sarlacc pit, you're going to be digested for all eternity, or for thousands of years, or whatever. You'll have your life will be unnaturally extended. 1, 2, 3, 4, 5, 6. Your score is, and I'm just going to do SC 3380. 1, 2, 3, 4, 5, 6. Your rank is, so again, they're adding unnecessary, well, it's kind of the opposite last time, where this time there are spaces after both of them. In the previous one, there were no spaces. And so the score was right, but the rank needed one. In this case, there's going to be 2 spaces after score. I'm just going to fix that right away. 3390. Return. Save. Chapter 33. Okay, so SC equals 300. Rank string equals Brad, and go to 3300. Thy game is over. You are trapped in the fortress for all eternity. Strange formatting. Your score is 300. Your rank is Brad. And that red on black is terrible looking. Really, really bad. Okay, so I'm going to change the cursor. But otherwise that works okay. And chapter 34. 3400. RAM. 1, 2, 3. Play again. 3410. Print. Clear. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 3420. Print. 1, 2, 3, 4, 5, 6, 7, 8, 9. My game is over. 3430. Print. This kind of business again. 3440. Print. 1, 2, 3. Would you like to? 3450. Print. 1, 2, 3, 4, 5. Play again. Why? And question 3460 get play again string, I guess. 3470 if PA string not equal yes or no, there's that same error, then 3460. 3480 if PA string equals y, then go to 10. 3490, otherwise we end. Okay, it's the same thing here. If PA string is not equal to y or PA string is not equal to n, then jump back to PA to read the keyboard again, waiting for either y or n. Save chapter 34. I think that's the last one. Okay, run 3400. Thy game is over. Would you like to play again? No? Yes? Oh, neither works. Oh, yeah. 3400. I think his logic... Yeah. This can't be an or. This has to be an and. If it's both, if it's not this and not that, then branch back. Okay, so double mistake there. Run 3400. Would you like to play again? No. Ready. Just quits. Would you like to play again? Yes. That goes back to line 10 and of course crashes. Okay, so that's chapter 34. Okay, and that was the end of the book. A note about the code from Jason Rekulak. When I started writing this book, I wanted to program an Impossible Fortress video game that would be playable on Commodore 64 emulators, hence the code excerpts at the start of every chapter. But over time, I realized that Billy and Mary's masterpiece would find a much larger audience and would be a lot more fun, and a lot less buggy, if it was designed and programmed for today's computers. Enter the amazing Dan and Jackie Viscido of Holy Wow Studios. They read the manuscript in an early stage, spent many hours discussing ideas with me, and created a brilliant faux 8-bit adaptation of the Impossible Fortress that you can play for free at my author website, jasonrekulak.com. My high score is 11,358, and I hope you'll leave me a note if you beat it. So yeah, the thing is, he probably could have got people to make a real C64 game, and maybe his game would have got even more attention had it actually run on a Commodore 64, even if he didn't include the whole listing in here. That would be awesome if he did. Anyway, that's okay. And then following that in the acknowledgments, he also mentions, my parents bought a Commodore 64 for our family in 1984 when a $600 computer seemed like an outrageously expensive luxury. Thanks, Mom and Dad, for everything, and thanks to developers' advice for keeping the C64 alive and well. Now, in 1984, the Commodore 64 was already down to about $200, so, but of course, with the disk drive and monitor and all that, price goes back up again. Okay, my YouTube stats say there are only 3 viewers still left this far into the video, so if you're one of those 3, please leave a comment below. Now, since this video isn't quite long enough yet, here's an extra possibly related thing that interested me. It's mostly conjecture, but I'll show the evidence I found and you can decide. I just noticed a new game was released for the PlayStation 4 called The Eternal Castle, and right away it made me think of The Impossible Fortress. Did The Eternal Castle draw some inspiration from The Impossible Fortress? By the way, I'll be showing various screenshots I took while researching this section, but I won't be dwelling on any one of them for very long, so just pause the video if you want to take your time reading them. So first, just to compare the names, the words fortress and castle are often used synonymously. I don't think anybody's going to argue that. And while they're not synonyms, the word impossible has a sort of eternal ring to it. Something truly impossible can never be done in all of eternity. So the two names are really, in my mind, very similar. But of course, that could just be a coincidence, but there are more similarities. The title screens for both games feature 8-bit styled art, and while the art style differs, both feature a castle or fortress atop a hill or mountain, towering over the surrounding gloomy landscape. The title fonts both have a 3D effect tilting away from the viewer, emphasizing how imposing the castle or fortress is. But here's where it gets really coincidental. We know The Impossible Fortress is about a fictional game from 1987, and it wasn't actually made until fairly recently in the Flash game I showed you. Well, the marketing for The Eternal Castle claims it is a remastered version of a game also from 1987. It reads, "It is an ambitious attempt to modernize an old classic in order to keep its memory alive. Through detailed research and hard work, the production team tried to expand the experience while keeping the same feel and emotional flow of the original masterpiece from 1987. So both games are from 1987, but The Eternal Castle was actually real, so there's a difference. Or was it? Apparently, this is just marketing hype. Really, it's a hoax. There was no original The Eternal Castle in 1987. This is a newly made game just meant to evoke a retro 1987 feel. Now, while the physical PS4 game that I noticed was just released in 2022, the game has actually been in the works for a while. The original Windows version was released on Steam in 2019, and then Switch and PlayStation downloadable versions were followed in 2020 and 2021. But the hoax about the game being from 1987 had actually been started 3 years even before the Windows release, presumably while The Eternal Castle was being developed, even from the time it was first conceived. It seems that the hoax began with a fake, as like a non-working version of The Eternal Castle, which was uploaded to the Internet Archive in September 2016. Check out, I think it's Phone's excellent analysis of the hoax. I just realized I've never said their name before. And there's a great thread on Twitter that I recommend you check out, link in the video description. Okay, so we've got The Eternal Castle originating in September 2016, but wait, The Impossible Fortress, the book, wasn't published until February 2017. So actually, The Eternal Castle seems to predate The Impossible Fortress. Who inspired who here? Well, it's common for review copies of books to be sent out before a book's release, and I did find some reviews of The Impossible Fortress going back to October 2016. That's just a month after the fake Eternal Castle was uploaded to archive.org. And of course, it takes a lot longer than a month to write a full-size novel. And the soundtrack for Impossible Fortress was released in June 2016. So it seems that Impossible Fortress was getting some publicity right around that same time, even before the book was officially released. So it certainly could have sparked the idea for The Eternal Castle. And this is an aside, but I just found out the same developers are the ones that recently had a lot of success with their new Trombone Champ game, which is pretty hilarious. Might want to check that out. And finally, I found a book review posted on January 12th, 2017 that says the Impossible Fortress has been generating a lot of buzz since last summer when the review copies came out, and rightfully so. So I think that clinches it for me. Lots of buzz during summer 2016 for a book about a game from 1987 called The Impossible Fortress, and then that same September 2016, a fake game called The Eternal Castle is uploaded to archive.org. So what do you think? Is it just a coincidence? Or did the developers of The Eternal Castle take some inspiration from the pre-release buzz of Jason Rekulak's book, The Impossible Fortress? And I just want to be clear, even if they did, I'm not claiming it's a ripoff. It's very much its own game, drawing more inspiration from cinematic platformers like Another World and Prince of Persia. Obviously, these developers put a lot of work into their game. And actually, they created, I think, the superior game, even if it was inspired from a very similar idea. So you never know where you might find inspiration for your own creative projects. Keep reading, keep being interested in things, and go from there. Okay, I hope you found that little extra interesting. I love stuff like this. Moving on. All right, does that fit in there? So in conclusion, I do like this book. I wish it were even better. If anybody else is making a novel or whatever, or actually anything like a movie or whatever, that's going to feature C64s as like a main plot point, please contact one of us YouTubers, or there's other experts online who could make what's already a pretty good thing even better by making it more accurate. Again, this isn't just nitpicking, in my opinion. This is kind of like a story of my life. No, well, it's not really. But it's about a 14-year-old Commodore 64 programmer from 1987. Hey, that was me, exactly. And when I read this book, instead of being completely thrilled with it, I have to kind of fight what I know is really true to keep enjoying the book. So I think us computer nerds are important too. In fact, aren't we the reason that a book like this even exists? It'd be even better if these were written more accurately, not like pedantically accurately, but you get what I'm saying? Could be done better, but still, I did enjoy the book. I did enjoy the story. And it's pretty cool that the Commodore 64 features so prominently it. Okay, so thanks to Jason Rekulak for writing this book. And if you do a sequel, maybe give me a call, eh? Thanks to all my patrons for their support. Thank you for watching, and we'll talk to you next time.
I was too